Hey there guys, hoping you are doing fine. Well, on to the next problem in the list. It is sorted perfectly in the order, and let's just refresh it so that we'll get the proper numbers instead of indices in the list. So the next problem is 72, I guess. Edit distances. We have a medium level problem. Let's see what it states. Given two strings, there are two strings, word1 and word2. Return the minimum number of operations. Well, we need a minimum number of operations. And what kind of operations? Let's see. Required to convert word1 to word2. Well, we have to convert word1 to word2. We have the following three operations permitted on a word. We can insert a character, delete a character, and replace a character. Well, let's see. Horse. Replace H with R. Now we have RORC and then remove R that is in the middle. We have rows and remove E, we have Ross. Seems like a tough one. Word 1 and word 2, we have to convert intention to execution. That's great. It's a pun. So we can ignore this TION thing entirely. That makes 1, 2, 3, 4, 5 operations. Remove T. Oh, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Intention we remove T. Inention replace I with E. Inention and with extension, execution, execution, and the length of the words will be between 0 and 500. That means probably can do order of n square 2 and word 1 and word 2 consists of lowercase English letters only. Well, let's see what we can do. We have three operations in hand. This one is simple to delete, but insert gives a question mark. Insert what? And replace also gives a question mark. Replace with what? ETION, ETION. Replace a character. Are there any hints? Well, there are not any. and we need a minimum number of operations here. Let's see the topics. String and DP, great, very helpful. Can we do the acceptance set is relatively very big, but I couldn't think of a way to solve this. Probably after completing the DP, we will have some easy time, I guess. Insert a character. Let's think in terms of DP. We can replace H with R or delete H entirely. Both are rows. Let's see. Steps, right? Minimum steps. Calculate steps. And count. And word. First word and then count. Instead, let's keep idx. If both are same, that's fine. Both are not same. We have to insert or update or delete. So there are two things we'll do, either update or do not update. Update by inserting, update by deleting, update by replacing. And word length will be between 0 and one more 0 and 0. What is the possible? Well, I did something. I did try something, but I'm not sure. Let's ask ChatGPT for the help. 72. The intuition was to do operation or not to do creation. Okay, got it, guys. Sorry. Instead of do, don't. Minimum of, sorry, one minimum of minimum of do and don't, which we are doing an operation and another we are not doing any operation. Let's see what we are doing wrong here. 00112. Okay. Find is equals to length of 14. If we don't do the operation, if we are doing, then we update both the pointers. or else we won't go any further. How to finish with the finish and help me to figure out a solution for myself by myself actually. Okay, that's fine. Looking comparing actors and branching into choices, but there are two main problems in your contact. Okay, do or don't operation. This logic only accounts for replace or delete from word, but every distance has three operations. Your recursion only covers delete, keeps one word, keep a word. Okay, replace a word, replace delete. You're using uncertain that makes the answer incorrect. When one he wrote when one word ends, remaining character must be deleted or uncertain. So word one ends need inserts. Okay. So if word one is ended, we need deletions. Okay. Counting operations in arguments. Better is to return cost, not keep count. So how to even correctly to compare characters branch and chunk match. Recursion plus try operation and no operation. Missing one operation. Wrong base logic. No memoization. Exponential term. Okay, we'll implement the memoization eventually. So guiding you toward correct solution of beautiful code. Define your cursor function. Minimum edits to convert. Okay. If I equals to the character matches, if they differ, try all three. Inserting, so plus one operation. Since we are inserting a character, into the word one will be a tie only. That means we have length of word one minus I values in the next. If we delete one, then we are deleting one value. And we are not moving forward because on the next value, because we are deleting an unnecessary value, but it still has one value. We are replacing a value, so we are moving forward. From these two, we are surely adding a value or replacing a value that is valid. So we are doing j plus 1, but deleting won't make a valid entry into the word 1. So we are doing an operation here which is removing one item. We are replacing one item, so we can skip the one because it becomes valid and we go forward. Here it won't become valid, but we go forward because it is removed. So let me do it again. Let's not make it count, and let's keep I and j beautifully. If I and j are at their end, then we shall return 0. If j go to the last word, then we have to delete the remaining values from the word 1. So return we reach to the end of the word 2. That means we have to insert values. Length of this is good, and if both the values change, we can move forward without any problem. Or else we'll do which is inserting delete. We are doing an operation for +1, so we are not doing an operation here, so not +1. And update, sorry, actually it is not insert, it is replace. Replace, delete and insert. So if we are deleting a value, then we are taking a value from the word 1, and it will not make sure we'll have something valid, so we are not skipping the j, but insert will make sure inserting one value will obviously insert a valid value, but since inserting means incrementing the word length, we'll still have the same number of values to its right, so it's not +1, and we don't need count here. Now we have to return the minimum of insert delete and replace. This will take so much time. This small value take 51 milliseconds, but we can make it good by using now this will go much faster, but we know this is making LRU cache is a good thing because we are storing I and j values. I mean, passing I and j value, we know what will be like. For example, here at some point I and j may be 2 and 3, and for here it may be 2 and 3 again, and here it may be 2 and 3. Since we are uh, trying to access a value 2 comma 3 multiple times, we are checking if 2 and 3 has previously returned from this LRU cache. This acts as a a memory cache holding thing where it will take I comma j values and see the corresponding answer from that. If it exists, then it will take the value answer from this, or else it will go on to do the operations. So let's try submitting this and see how this will go, and let's also see what other answers are. We used the LRU cache too. Oh, that's one great way to do it, and it is simple. Guys, I have to attend for a task, so I'm leaving here. We'll continue from where we have left as soon as I return. So continuing where we have left, let's implement it. With elegance like the one we have seen before. If I equal to 0 and j equals to the 0 and so on, or return I or j. Let's see. with checking -1, J-1, and we're skipping -1, J-1. Oh, I guess this will be fine. And submitting it again. Much elegant. Or maybe it can be even shortened by doing this. So we are using LRU cache, which is acting as a dynamic programming instance which will store the values for I and j. For example, if I equals to 1 and j equals to 2, then we'll get, whenever we pass I equal to 1 and j equals to 2, we'll get the same result. So instead of going through the hassle multiple times, like if I equals to 1 and j equals to 2 came more than once, then we use it from the first. I mean, we use the result that's stored here for the first instance, which came from the first instance. Then we'll use it. If it is the first time, then the entire calculation will be done. So what we are doing here is, if I and j are 0, or one of I and j are 0, we'll return the I or j. If both are 0, then we'll return 0. If one of them is 0, we'll return the other value. And here we are checking if both the values are same at the particular index, then we can skip it because we don't need to do any operation on that. And here we are trying to do an insert operation. Here, since inserting a value will increment the word 1 length, we are not changing i's position. I will be at the same position as before, but it is an inserted value, like we move to the forward, but at that position we inserted a value which will obviously, for example, if we are at ith position, which is at O, and if we have to insert some value to its front, then we'll insert a value to the front and we'll move forward, which will be somewhere between O and R, but there are still 3 values to its right, so we are not decrementing or incrementing the I. Here what we are doing is deleting a value, and deleting won't make both the values equal or satisfy the word 2, so we are not changing j's position. And finally we are replacing it. Replacing it will make both the values validated, and since both the values are validated, we can move forward in the word 1 and move forward in the word 2 again. And by that time we reach here, if there are few words left out, we have to delete them. or we reached the end of the word 1 but word 2 still exists, then we have to insert. So we'll return how many words to be returned, which can be I or J, and sorry, which will be J. And if we reach the end of the word 2, then we have to check how many words should be deleted, which will be I, and it will back propagate the values and will take the minimum of them all and increment +1, because each operation, each of these represents operation which will take +1 which is a +1 operation. So we are doing +1 and finally we'll return the answer what we got here. But instead of doing LRU cache, I don't know, let's see how it can be done without LRU cache. Let's give this how to do it without LRU cache. And again, the time complexity here would be order of 1, 2, 3, 3 power n, and is the time complexity 3 power n. We have a green down time complexity without without memoization. The recursion explores 3 branches every time characters don't match. Worst case, every character mismatches. Time complexity is order of 3 power m plus n, where I guess where m and n will be the length of word 1 and word 2. This will TLB and lead to time limit exceeded with memoization or bottom of DP. Time complexity will be order of m into n and space complexity will be order of m into n, which is what we call it, recursion stack. The bottom of DP version. M command equivalence of the word 1 and 2. Oh, we keep dp equals to 0 into n plus 1. Okay, we have a list. We created a 2D list, and for each I and j values we are updating the list. All deletes, all inserts. And here we are deleting all and we are inserting all. For I in range of 1 plus 1 plus 1. For j in range of 1 command plus 1 j minus 1. dp of I equals j equals to j minus 1 j minus 1 I comma dp of I is j. Okay, if both are same, we'll take the previous value and keep it. or else we will increment the previous value, minimum of previous value, and we'll do +1 to it. M, N. At M, command position, since we go through M+1 and N+1, we will check the final answer at M, N, which is reaching the, changing the word to completely. Yes, because every row only depends on previous row. If you want, I can guide you step by step to reduce to 1 DPI optimization. So this update thing, should we see it? Here the space complexity will be order of m into n, and our solution also order of m into n. Yes. So the time complexity will be order of m into n for sure, but it is more optimal. This is the best. Oh, 3 power m plus n, recursive plus LR cache would be order of m into n. Okay, well, I got it. Yes. So there can be 3 ways: memoization, which is a recursive solution; bottom up, which is an iterative way of doing things. Maybe we can call it tabulation; and an optimal solution. And everything won't have an optimal solution, only few. Let's break your question not clearly and for okay. How to do it without. You need to convert the repeating to review table. So what's more still gives optimal complexity. Can we optimize it to order of m is time complexity of your recursive solution. There are 3 ways. Every mismatch exponential. Okay. First case, every character in which call branches into 3 new cells. Calls. Depth is roughly n plus 1 approximate complexity. Well, that's what we have. I have asked for, but but we keep but notice to compute d of I comma j, you only need so maintain previous of j, update current of j, right? Sum is greater than n. Previous. So mode 1 will always be greater than mode 2. Previously m plus 1. Created a list. Current range of, okay. We have a current list which is of size m. So current of j equals to previous of j minus 1, or else previous of j. So all operations, for example, at 0th position, we won't do any operation. At 1, we will do 1. At 2, we will do 2 operations. 3 operations, or 4 operations. So at every step, we are making an operation here. So here we are checking doing all operations. So replacing would mean I didn't understand. I'll look into it. For now, this is the solution. I hope you guys understood the intuition. If you like the video, upload it and share it with your friends, and don't forget to subscribe to the channel. We'll meet you again with another video. Until then, keep learning and keep pushing hard. So that's it, guys. Goodbye.